Hi guys, my name is RAVINKUMAR. Unlucky VISWANATHAN. My matrix number is 07DE19F1020. So today I'm gonna show you how to do practical lab 1 for power system by using Matlab. So Matlab is a software, so you can download it from online. So I think it's you can download it from the correct version. So there is many YouTube videos that show you how to download it. So you have to download in order to do this lab work. Okay, so let me go through this thing. So okay, this is Polytechnic Balus the practical work 1. So you have to design a solar PV power generation. So it's like the PV array thing lah. So see, yeah, single array with 2020 50-20 configuration using Matlab Simulink. So the instructions, so this is what your PV array is, you have to add the parameters and rated values in the PV array later. So I'll teach you guys, so don't worry, you just follow my steps. Okay, so that's all I think. So you'll get back to Matlab. So okay, so once you install Matlab, we're gonna open it the Matlab. So when the Matlab open, it will take some time. If you are faster booting computer, then it will load up fast. So if you are slow computer, don't worry, it will take some time, but still it will work. So go to Simulink, you press Simulink here, and then this page will all start open. So once it open, click this blank model. You click this. So you click this, it will start the Simulink. So it will take some time. Correcting model and stuff. Okay, once you created, what if you have to do is to save in order to be like, you don't lose it. So we save it first. So I'll put this as practical. You cannot leave space for this thing, so you have to underscore it. Okay, and you're saving practical test. Okay, alright, so all we have to do is a solar power generation, design a solar power generation. So first thing we need to do, whatever we do in Simulink, we need this thing to find the measurements. So this thing called name as power give, yes, this thing, enter for search. What's this thing? So you just drag it, put it here. Alright, this thing is the one who will calculate. It's like power source for this Simulink. Okay, then second thing is we need the PV array. Exactly, we need the PV array. So PV array, search for it. It is the PV array. Alright, you have to put this. Alright, so once you put this, you double click on this. So one tab will open like this. So you have to take this. Okay, you see this, you have to follow this thing to here. So parallel string is 50. You see here 50 times 20. So 50 times 20, which is undefined. This thing no need to change. But here they say end cell is 54, not 60. You have to change this. Open circuit value is VOC 32.9. Short circuit ISC is value as 8.21 ampere. You don't need to put ampere voltage because they already value here, so you don't need to add it. So maximum point VMP is 26.4. Yeah, 26.4. And then IMP is 7.58. So this temperature and this thing you need to change. So it's hurry. So that's the thing. You need to change anything else. Click OK. Finish. Done. Next thing, we need two constant for these two input. So constants. Such. Okay. Once you put constant, you have to put two constant here. One and one more. You have to input, right? So yeah, So this thing make the constant value as 1000 and this thing as 25. Okay, done. Now what you have to do is we need a current measurement. So to measure current you have to get a current measure. So okay guys, so when we want to measure current we will connect to a series circuit, am I right? So this thing, why it has only one input and two output, this thing will connect as a series. So that's why it has two output and one input. So you see, we just connect it here. So later I will do, we not yet have the ohm yet, the resistor yet. So next I think this thing is to ground, so excessive it is negative, right? So excessive current will go to the ground, so we need to add ground here. Ground. Yeah, here's ground. So not this one, you need to go down, you need to find in Simulink. Okay, ground for neutral 3-phase here, because we're using 3-phase, right? Oh, sorry, not this. Technical error. Not this. 3-phase is for practical work. 4 and 5, 3 and 4. So this thing, not using practical as 3-phase. So just connect to this. Done. So just extend it. Okay, to look much more cleaner. So then we need as I say, the resistor. So resistor is RLC branch. To search for RLC branch, you will get this series RLC branch, because we're gonna connect it to series, right? So we're gonna rotate it. So just press Control plus R, so it will rotate. Double click on it. We just need the ohm, not the inductance or capacitance. So we just need the ohm and the resistance. So in order we do this practical work, we have to do the calculation first. So let me show you my calculations. This is what I calculated. Okay, you see the calculation here. Okay, VT, VI, and we get the ohm 1.393. So that's ohm. We're gonna put it here. 1.393. Apply. Sorry. Close. Yes. Alright. Once you put this thing, so positive connect to the here, this was negative, and this thing have to connect to the ground. Yeah, we need one more ground actually. Ground. Such. Not this, this ground. Yeah, exactly. Do I put it or not? No. Okay. Yeah. Okay. Once the RLC is connect, and then this thing. So once it connects, so this thing is some current measurement. So this thing, you see, we need to connect it to the display to view the data, like basically how you want to see the current measurement. Just the current won't show you if in the simulators. So we need a display. Yeah, display. Go for display. Is display. This one, display. Okay, put it here. So connect this thing to the display. Done. But if you want to get the oscilloscope, because we need to get the graph. If you see these questions, they do ask for the power waveform signal. So if you want a waveform signal, you need a oscilloscope. Oh, yeah, oscillator. oscilloscope like basically. So you need the oscilloscope. How do you get an oscilloscope? You need a scope. Yeah, you could just go search the scope and you'll get the scope. So you just put it here to connect. So whenever it comes, you will just can see the graph. So and then we want to find, basically we are finding current, so you will find the voltage also. So how are we going to find the voltage? We need a voltage measure. Let me switch voltage. It should come. No, am I going too fast? Voltage measure. Okay, this thing. If you see, a current has one input, two output, and this thing has two input, one output. This because voltage is a parallel way to find voltage. So that's why it has two input but only one output. So that's how parallel works, right? You have to connect it outside to calculate the voltage. If it's current, you have to connect it to one loop. It's like one circle. It's a series. That's why it has a series, and this thing will go, and then this. So that's why this is a parallel circuit. So parallel way to find out voltage. So how you gonna put it in a parallel circuit? So if you see this thing, I will connect to the negative side of the resistance, and the one more is straight down to here. Finish. So you check the positive side and the negative side. You can find the voltage here. Done. So for this measurement, you still need to get the display, right? So one more time, display. Where is display? One search. Oh, it's here. Okay, display, and obviously you need a scope as well. Let's go scope. Okay. So you just connect it here, and exactly the same thing what we just did. So if you can track down. Okay, one more thing I want to show you is how to calculate power. What's the formula to find the power? So we all know the formula to find the power is P equals to VI. So basically voltage times with current, we will get the power. So that's how we're going to do it. So to find that, we need the multiply blocks. See the product. You see this product will eventually product the voltage and the current. So what you have to connect is, we just have to connect these. Okay, we have to connect these to here, the voltage, and one more is from here. And obviously to power also we need the display as well. So display, search for display and scroll down, you will see display. And you need the scope as well to find the graph, the oscillator graph, oscilloscope. Okay, once done. Okay, if you see, this is the diagram we built. I think this is perfect enough, correct. So to check whether it's correct or not, we will check it, we will run. So we run and see, and boom, is that correct? Is that the calculation correct? Let me check the calculation. What we get, total power P total current we have to get is current is 379 ampere. We got 379. Wow, that's great. and then the voltage we have to get is 528 voltage, and we got it, and the power as well. So this is exponent plus 10 is simply to 10 the power of 5. So it's like correct, it's kilowatt 10 the power of 5. 1 2 3 4 5. So you will have like two zeros behind, so it's 200 kilowatt. So it's correct. So our project is success, guys. We already do the PW1. So this thing, so we want to check the oscilloscope, right? So yeah, this is oscilloscope. You can see the time 3 5 to 8, it's running straight. You can see, let me zoom it for you guys. Zoom, guys, just press it. Oh, I actually press it too higher. Minus. Go down. Yeah. Okay, you can see 15258. That's what our reading says. So it's correct. And this thing, let me see the scope for this thing. 179, correct? What? 179. So if you want to see it bigger screen, you just click, go to this thing, zoom it. See, 179. You'll see the straight line 179. Exactly what we saw in this thing. So it's nearly 158, but still in 1528. It has a point form value on it. So we will go to the power. 200 kilowatt. See, 200 kilowatt. So it's like similar in a decimal place, but nonetheless, if you round off it, you will get the same thing. You see, 10 the power of 5. You will get this, correct? So done. We are done. This thing, power form, and yeah, basically we have done everything. We already plot the thing, and we already done the thing. So I think that's all from me today, guys. So thank you, take care, and bye bye. See you all in the next video, guys. Bye bye. Don't forget to subscribe me.